Factoring quadratic trinomials. So obviously we're going to be dealing with trinomials. So prime polynomial is a polynomial that cannot be written as a product of two polynomials with integer coefficients. So what we're going to do, we're going to make an x. Actually, I'm going to make it up here so that you can see how I'm going to do this. Ax squared plus bx plus c. That's standard form for a trinomial. What we're going to do is we're going to multiply these coefficients together. And they're going to go up front. Okay? Then we are going to take, maybe if this moves, there we go. We're going to take our b value. And it's going to go here. So the two positions that are here, this one here, those two positions mean when a plus, nope, I don't want to do a plus, when the left factor plus the right factor equal b. So we're going to do that. So I'm actually going, I'll do this one. So I'm going to take the factor right here. The factor right here, 1. And this is 18. So I'm going to multiply these two together and I'm going to get 18. Then I'm going to take this number right here and I'm going to put it right here. So we want to find all the factors of 18. So our factors of 18 are 1 and 18, 2 and 9, but we also have negative 1, negative 18, negative 2, negative 9, 3 and 6, and negative 3 and negative 6. So which set, when you add them together, is going to get negative 9? So if I look at this, I'll do this color. If I add that, that's going to get me 19. If I add this, I'm going to get 11. If I add this, I get positive 9 up, but I want negative 9. So if I was to come over here, these two right here would get me negative 9. So I'm going to put negatives 3 and negative 6. Now, I'm actually going to go ahead and put an X on those, because you see how this is going to be an X, just so that you can see this. So I still have x squared. I still have 18. But in the middle, I'm going to replace the negative 9x with negative 3x minus 6x. Does this part right here still add to this number right here? It does. It still adds to that. So we're perfectly fine in what we're doing. So I'm going to put a slash here. I'm going to look at the first two and I'm going to say, oh, they both have an x in common. When I take out that x, I get x minus 3. Then I'm going to look at, on the right-hand side of the red line, I take out a negative 6, and I'm left with x minus 3. So I have x minus 3 in common, and then I have x minus 6. Okay, let's try it over here. I take these two numbers and I multiply them together and I get negative 14. Then I take the b value, which is 5, and I put it here. So I need to know all the factors of negative 14 that add to 5. So I have 1 and negative 14 I have negative 1 and positive 14. I have 2 and negative 7, and I have negative 2 and positive 7. Which one, when they add together, are going to get you 5? So this one is the one that would add together to get 5. So I'm going to put negative 2x, and I'm going to put 7x. So when I write this out, I'm going to get x squared. I'm going to get minus 2x plus 7x minus 14. And I'm going to do the same thing I just did a moment ago. Oops. Put my slash here. Take out my x minus 2. Take out my 7, x minus 2. What do they have in common? X minus 2. What's left over? X plus 7. Okay, so we're going to come over to this one. We're going to do the exact same thing that we've just done. I'm going to multiply these two numbers together, and I'm going to get negative 4. Then I'm going to take the b value, and I'm going to put it right here. Then, what are the factors of negative 4? So 1 and negative 4, and negative 1 and positive 4. 2 and negative 2, and negative 2 and 2. Which one, when you add them together, will get you a negative 3? This one right here. So 1 and negative 4. Now, could I write it negative 4 and 1? Sure. Do it that way. Does it matter? No. So x squared minus 4x plus x minus 4. Take out an x, and I'm left with x minus 4. Now, what am I taking out? What's the only thing that they have in common? They have a common 1. 1 is the only thing that they have in common, so x minus 4. So they have an x minus 4, and we have an x plus 1. Okay, let's come over here to this one. I'm going to multiply these two numbers together. I'm going to get negative 40, and they have to add to 3. So 1 and negative 40, 2 and negative 20, 3, nope, 4 and negative 10, 5 and negative 8. Or I have negative 140, negative 220, negative 410, and negative 5, 8. Which one adds to get positive 3? This one. So negative 5 and 8. So I get x squared minus 5x plus 8x minus 40. Cut it right here. What do they have in common? They have in common an x. Oops. X minus 5. What do they have in common? They have an 8 in common. X minus 5. So I've got x minus 5. And I've got x plus 8. Oh, I missed a whole row. Oops. Okay, so I get 8 and negative 4. So my factors of 8 are 1 and 8, 2 and 4, negative 1, negative 8, negative 2, negative 4. Oh, none of those add to negative 4. This would add to 9. This would add to 6. This is negative 9, and this is negative 6. So this is prime. Okay, sorry about that. So I take these numbers, I multiply them together, I get 6, 7. So 1 and 6, 2 and 3, negative 1, negative 6, negative 2, negative 3. Now, do you have to write them all out every time? No. If you figure out which one it is first, you don't have to do the whole thing. Now, I am purposely putting the 1 second so that you can see what happens. Because, again, if I cut this, I would get x plus 6. And the fact that the only thing that these two have in common is a 1. You've got to write that 1. And that's why I had us do this one this way. So x plus 6 and x plus 1. And last of this kind, so this is 12, this is negative 8. So 1 and 12, 2 and 6, 3 and 4. Negative 1, negative 12, negative 2, negative 6, negative 3, negative 4. Now, you know it's supposed to add to a negative 8, so you didn't even have to write those down. You knew it had to be this section right here, so you could just write that section. Just make sure that the negatives are actually on it. So we get x squared minus 2x minus 6x plus 12. Go right here. I take out an x, left with x minus 2. The leading coefficient on this next part is negative, so I'm going to put a negative, and I get x minus 2 because we want the parentheses to come out to be exactly the same. Oops, I didn't do it in the opposite color. Okay. Now, so now we have x squared minus 6x plus 9. I'm actually going to skip that one. We're going to come down here. Okay, so on this one, do you notice that each one of these is even? So the first step that we have to do is we have to take out the GCF. What do they all have in common? Oopsie daisy. They all have in common 2. So I'm going to get 2x squared plus 9x minus 5. So that's step 1. Then I need to do this right here. So I've got negative 10 adds to 9. So we know that the answer has to be positive. So I'm going to do negative 1 and 10, negative 2 and 5. This one right here adds to negative 9. So I'm going to put negative 1 and 10. Now, mind you, boys and girls, you've got to have that 2 out front. Okay, that is a part of the problem. You've got to have that out front. So 2x squared minus x plus 10x minus 5. So I go here. So the 2 stays where it is on the outside. I take out an x, and when I take out that x, I get, how about I write the 2? 2x minus 1. Then on the second one, I can take out a 5. And I'm left with 2x minus 1. See how they're still the same? Mind you, I keep the 2 out front. I have a 2x minus 1, and the leftovers are x plus 5. And if you were to multiply those back out, you would get the original equation, or the original expression. So here, I don't know what I wrote on there. They have nothing in common, so I don't need to take out a GCF. Ignore that. That was me typing. This right here, if I multiply that together, I would get 42. And it has to come up with negative 17. So, we know it needs to add to be negative. So negative 1, negative 42, negative 2, negative 21, negative 3, negative 14. Oh, we have it right there. Do I need to go further? No. Can I go further? Yes. So I have 2x squared minus 3x minus 14x plus 21. Draw my line here. What do they have in common? They have an x in common. I get 2x minus 3. On this side, I take out a negative 7, and I get 2x minus 3. They have the 2x minus 3 in common, and they have the x minus 7 left over. Okay.